Hey guys, we're going to be jumping into chapter 9 here where we're going to be talking about three-dimensional geometry. So today we're talking about solids. So what you're going to learn is to identify solids, parts of solids, and skew line segments. Let's go ahead and jump in. I'm going to give you a warning right now. A lot of vocab in this section, so start loosening up the old wrist muscles. All right, so solids are objects that do not lie flat in a plane. They have length, width, and height. In other words, these are the things that you probably would call a 3D object, three-dimensional. The reason it's called a three-dimensional object is because it has 1 dimension, 2 dimensions, 3 dimensions. So that's what makes it a three-dimensional object versus a line has 1 dimension. A shape has 2 dimensions. It has 1 dimension, 2 dimensions. This has 3 dimensions where there's my awesome cube. It has a height, and it has a width, and then it also has a length. So 3 dimensions here. So again, 1D, 2D, 3D. All right, I need you to pause and copy all of this down. I know it's a lot, but copy all of it, including the diagrams in the middle. Every word that's on this slide, I need copied into your notebooks. All right, so a prism is a solid with 2 parallel bases that are congruent polygons. The lateral faces are always parallelograms. Okay, so here is a base that is congruent to this base right here, and they are parallel, which means if I were to extend this plane off in all directions, and I were to extend this plane off in all directions, these 2 planes would never ever run into each other. All right, so that's the way a prism works. A prism is named for the shape of its bases. So this has a 1, 2, 3, 4, 5-sided base, so it's a pentagonal prism. A pyramid is a solid with exactly 1 base, which is a polygon. The lateral faces are triangles, so the ones on the side are triangles. Pyramids are also named for the shape of their base, so this would be a square pyramid because this base right here is a square. So get used to that naming convention, and let's keep going here. All right, more vocabulary, so pause and copy this down. A cylinder is a solid with 2 bases that are parallel, congruent circles. So again, these 2 circles, if this plane were to extend off in all directions, they would never interact with one another. A cone is a solid with exactly 1 circular base and what's called a vertex right here. So this is a circular base and then 1 vertex. A polyhedron is a solid whose faces are polygons. Of the solids above, only prisms and pyramids are polyhedrons. So these are not polyhedrons because they have circles instead of polygons. A circle is not a polygon. Polygon has all straight edges. Let's keep going. All right, so here is your daily funny. Now this is just mean. If you are ever in the company of one of these and you start singing this particular song, just don't. It's not kind. If you're happy and you know it, clap your... Oh, T-Rex can't clap his hands because his arms are too short. That's sad. All right, so naming solids and their parts. It says describe the base, name the figure, and name RL. All right, so the base here first, let's start with the base, is a circle. Okay, so we'd say the base is a circle. And then it tells us to name the figure. Well, this is a base with a single vertex up here, so that is a cone. So the figure is a cone. And then it says, and name RL. Well, this is a circle with a midpoint, and RL is a line that goes through that. So I would say RL is a diameter. So I'm just labeling the things that it asks me to. Make sure you have this whole question and image copied into your notes. Here's one for you to try. Go ahead and pause. The answer will be up in 3, 2, 1. All right, here's what I got. This is a pentagonal prism. JK is a lateral edge, and J and K are vertices. This is the plural of the word vertex. So J is a vertex, K is a vertex. When you have more than one vertex, you have vertices. Let's keep moving. All right, recognizing solids. It says a stage crew for the school play constructed the ramp shown. Whoops. Name the 3 solids used to construct the ramp. So I have 3 solids here. I would say section A would be, well, first of all, let's notice that all of these sides here are all created by, looks like it would be rectangles, kind of, or some type of parallelogram. So section A I would call a triangular prism because this is a base right here. Triangular prism. And here I'll do A so we know what it is. B I'm looking at, and it looks like a rectangular prism. Bases that are rectangles. With a rectangular prism, it can become confusing, which is the base and which is lateral sides. And then section C is, well, these are all rectangles on the side. So I have this right here. I have 1, 2, 3, 4, 5 sides. So we're going to call that a pentagonal prism. And let's keep going. All right, here's one for you. Try. It says, name 2 solids that can be used to make up section C. I'm only looking at this. So if I were to divide this up in some way, what could it be? All right, the answer will be up in 3, 2, 1. All right, so here's what I see. You may not see exactly the same thing, but if I cut down right here, this creates a trapezoid as a base. So I'd call that a trapezoidal prism. And then it leaves right here a rectangle, so I'd call that a rectangular prism. Let's keep going. Skew lines are lines that do not intersect, but they're not parallel, which means that they are not in the same plane. So right here, pause and copy this down. It says, name a pair of skew line segments and a pair of parallel line segments in the figure. All right, so skew lines are going to be lines that if were to continue in all directions would never ever intersect each other. Well, right here I have this line that goes through AB, and then I have a line that would go, I don't know, through here, DE, and even though they may look like they're drawn, if I were to think about this in terms of a 3-dimensional figure, this line and this line are not in the same plane. This one's kind of sitting up on the side and pointing up. And this one's laying flat and going in this direction. So this plane is over here and this plane is over here. These 2 lines would never ever intersect each other, but they're not parallel. Okay, so we would say that we could say ED and AB. And you could either refer to this as the lines, which I did, or if you didn't put the arrow in, that'd be line segments. Are skew lines. And parallel lines would be lines that are in the same plane that never intersect. Well, to me it looks like this and this right here would be parallel. So I'm going to say FG and BC are parallel. Put my lines up on it. All right, so that's all skew lines are, lines that would never intersect, but they're not in the same plane, so they're not called parallel. Here's one for you to try. Go and pause. The answer will be up in 3, 2, 1. All right, here's what I got. You may not have the same lines. That's perfectly fine. There are actually a lot of different options over here, but I said that EB and AB intersect right here at B. And they're not skew because they're intersecting. That's what the definition of a skew line is. So that one should have been pretty easy for you. That's it for today. So hopefully you took good notes. I will see you all in class.